Good afternoon, my name's Andrew Gunn. I teach a Year 3-4 class in a primary school on Monday and Tuesday. We started the project with a volunteer pupil who I got to come into the class wearing this tinfoil robotic suit, and I asked the pupils to come in and give instructions to the pupil robot to walk around the class. Going forwards 3 steps, turning right, going forwards. If you hit a table, go back 2 steps, and so on. And so that started our whole project. And then I wanted pupils to ask questions about what they wanted to find out. So I gave them all a post-it note, and I gave them a few minutes to write down any questions that they had that they wanted to find out about robotics. And I used those post-it notes to help inform my planning for future lessons. So we then discussed the evolution of machines, going back to the 1800s, when the Luddites tried to slow mechanisation of factories by breaking machinery up at night. And 200 years later, people are still afraid of losing their jobs with all the robots that you find in car factories. And at this point, I like to show the children a typical car factory crammed full of robots, and they are absolutely amazed to find that there's hardly any human beings walking around those factories at all. There's also a lovely video of a trial of humanoids in Japanese hospitals, and the robots there look very much like humans. And again, that's quite scary for children, but they can see how much progress has been made in robotics. At that point, we do a kinesthetic activity, and I went to the Computer Science for Fun website, which has some fantastic resources, including this one on the cardboard face. So here's a mouth, and then we have 2 eyes, and then we have 2 eyebrows. And I ask for 6 volunteers, and each of the pupils comes up and holds one of these items of the face. And they're basically given the program that when they hear a loud noise, they have to move the face in one way. When they hear a happy sound, they move the face and mouth in a different way. And when they hear an angry sound, again, they have different instructions on where to move the eyes and eyebrows and so on. And then we want to move on to actually drawing robotic arms. So they've seen some in action on videos, and so I get them to draw their own robotic arm. And then we try and build it with cardboard. And at this point, I show them the CBIS education site, which has got some cardboard templates which pupils can use. Or they can just use their own design. So I give them stacks of cardboard, straws, doweling, pencils, and I give them some time to come up with their own cardboard robotic arm, but they're making up in teams. And then we have a little vote to see which of the robotic arms is the most effective. After that, we have a virtual robotic arm in Scratch. And so they come up and they try and control the virtual robotic arm. And I give them some time to tinker then with the Scratch program so that they can get the arm to do different things in the program. After a while, I like to move on to a real robotic arm, or at least a toy virtual robotic arm, which is this one here, commonly available in many good stores. And this comes with some easy-to-use software that even your reception pupils could use. You basically click on different letters and the robotic arm moves around. After a while, I then introduce them to the Fuse Basic box, which comes with a Raspberry Pi. And we plug in the robotic arm in the back. And I teach the children how to use some simple, basic programming language to get the robotic arm to move, which is great fun. Pupils have really enjoyed learning about robotics, and in later lessons I've also used Ozobot and Lego We Do, which I know quite a few primary schools are familiar with. And you can spend many, many lessons on this. If you want to find out more information, you can go to my training website, do a Google search for Andrew Gunn TLC.